So we're talking about the substitution method of solving for integrals. I took one of the evens from Stewart's 5-5 section. And this one looked like a little hard, at least looked that way. Of course, we know that if it's one of the problems, then there's a way to do it. They've not just thrown, unsolvable for a first time through student. So we know this is solvable just because it's in a textbook, right? It's one of the problems. So it's the integral of dt over cosine squared t times the square root of 1 plus tangent t. So when we look at this, I'm thinking, either cosine or tangent. We're gonna substitute a u for one of these. So it's either going to be u squared t, or it's going to be 1 plus u for tangent t. So let's say that we were lucky and we started with substituting for tangent t. So what are we going to substitute for? Oh boy, what are we going to substitute for? The cosine or the tangent, as I just said. Let's try the tangent and see what happens. So you can't get very far with these trig ones unless you know your identities. And I've got some videos hiding out there somewhere on what the basic equations are. And if you're doing the Udemy course, I've got a video on the basic derivatives of these. So the derivative of the tangent is the secant squared. If u equals tangent of t, then du is secant squared t dt. So du dt equals secant squared. Multiply both sides by dt, and we get du equals secant squared t dt. Now, hopefully you remember that secant is 1 over the cosine, which is very convenient, isn't it? Because what we had, let me go back, is we have a cosine squared. So we have 1 over cosine squared. That's secant squared. And so the fact that the derivative of the tangent of t is secant squared is mighty convenient. So let's go back here. So if u equals tangent of t and du equals secant squared t dt, then this complicated turns out to be this, because du is the 1 over cosine squared dt, and then 1 plus u is the 1 plus tangent of t. So now we have something that looks a lot more manageable. Why? Because this is a power. 1 plus u raised to the minus 1/2. Again, remember, a square root is a raising to the 1/2 power. And then if it's in the denominator, then it's the negative 1/2 power. So that means when we take this, we are basically asking this. What is the integral of 1 plus u to the minus 1/2 power du? And so the way we do that is we raise this a power, 1/2, negative 1/2 plus 1 is 1/2. And then we need a number in front that's going to cancel out. So 1/2 times 2, and it cancels out. And so this is the integral of this. Now we can substitute the u back in. What was u? U is tangent of t. And square root is to the 1/2 power. So 2 times the square root of 1 plus tangent t. Mischief managed, and we're done.